Hello, and welcome to the third event in a week of lectures and webinars to mark the 40th anniversary of the IGS. In this week, we're showcasing great thinking and insights from IGS members around the world, and also giving you the opportunity to quiz the officers and our speakers on the activities of the IGS. My name is John Krause, and I am the IGS's Executive Director. Please note today's event is being recorded so that we can share it with those members who were unable to make the live session. It's my pleasure today to introduce Kasia Zamara and David Shercliff. Dr. Kasia Zamara is a geotechnical engineer with experience working for international consultancies and contractors in Poland, the UK and New Zealand, working for Tensar, where she is Stabilization Application Manager, Eastern Hemisphere. Kasia has been an active member of the IGS since 2009, organizing chapter seminars. She's been a co-opted member of the IGS Council and a member of the IGS Sustainability Committee and Diversity Task Force. David Shercliff is Chief Engineer at ABG Geosynthetics Limited in the UK, spanning a wide range of sustainable civils and building projects from blue and green roofing to landfill containment, ground stabilization and reinforcement, porous paving and structural drainage applications. David is a member of the IGS Sustainability Committee, and he's passionate to find and share innovative green solutions to earthwork structures using geosynthetics. Kasia and David are going to present on 40 years saving the Earth. We'll welcome any questions you have, so please do put those into the Q&A box and share those questions and comments, and we'll try and answer them. David, you're going to speak first, so over to you.
Thanks, John. I'll just share my screen. And thank you for joining us. The title, 40 Years Saving the Earth, sounds a bit grand, but we hope to justify what we mean as we go along. So what we're looking back is over 40 years of the sustainable benefits of using geosynthetics. And I thought it'd be fun to just think back a bit what was happening 40 years ago. Well, actually, it was when I first entered the geosynthetics industry, and I was a science teacher. I'd been a civil engineer before that as well. And here am I doing a test on a testometric. And interestingly, Kasia was born. So she's looking very cute there. So it's a generational thing, and we thought it would be fun to just share our views and how we see things in my 40 years and Kasia's few years in geosynthetics. Of course, 40 years ago is what we're celebrating. The IGS was born, and I'd encourage you to look at the strategy document, very comprehensive, and there will be questions that you can ask Jihan after this and other officers. So just to give you a scale, this talks about all the various meetings, etc., and how it developed. But our focus is on sustainability. And just to get some kind of way of bringing all this together, it's what we're talking about is measurements of embodied carbon and other sustainable benefits. But this is the area where we can put a number to the benefits of geosynthetics. And of course, embodied carbon, at the moment, the most reliable and consistent figure to talk about is the value of cradle to the end of construction. There are some operational carbon values which can be worked out, but the majority is the embodied carbon, the carbon that's been already used up in getting the product made and then to site and then constructed. One of the other areas we must be aware of now, and it's growing all the time, is that there's a loss or a shortage in the major products which are used in ground engineering. And just as an illustration, the Burj Khalifa used 110,000 metric tons of concrete, and the sand that's used in that concrete had to be imported from Australia. So if we're starting talking about carbon costs, etc., we're now talking about the shortage of materials even to make concrete structures. So when I'm talking about saving the Earth, we're talking about saving precious, rare materials now. So quarried stone, which obviously has to be graded, etc. We're talking about drainage gravels, which have to be a certain size, often rounded, river gravels, sands, which have to be grit sands, as we just illustrated, for bedding layers and filter layers, quarried clay, The clay, if it's going to be usable as an impermeable liner, has to have the right permeability level, right porosity when it's put in. Concrete itself, all the components for concrete are rare. And of course, it's well known that the production of concrete is one of the most carbon hungry materials. So, and minimizing the use of concrete so it can be used in units or poured. And then, of course, asphalt for our roads. So the cost of actually getting those materials to site, first you have to actually excavate them and grade them on site. There'll be blasting involved, other environmental issues such as dust and control, and then at the end of its life, restoring the quarry to a landscaped feature. And of course, we've got to transport the material, sometimes many miles or kilometers, and typically 60 to 100 miles to get to any one site. And often the sites are difficult to get to. And of course, these are heavily loaded vehicles which have to get through difficult places. And of course, this damages the road, which then has another on cost in terms of money, but also on the environment. Then when you get to site, often you have to cut to formation to get the materials in the first place. And if you have excess materials, they have to be carted away. I mentioned maintenance, but of course, over the period of time that the material's there, it also has to be maintained, especially the surface layers. So where are geosynthetics used? And what we're aiming to do all the time is looking to save on those materials. And of course, in railways and in roads, we're looking at reducing thicknesses of roadstone or ballast, or stabilizing them, making them last longer than they would have done otherwise. In bridge structures, instead of filling with concrete or very large concrete reinforced walls, the concept of reinforced earth has been around for many years now. And wall and slope embankment stabilization on soft soils as well are areas where otherwise large amounts of excavation would have had to occur. And of course, coastal protection, where many layers of filter layers are used. And with a well-selected geotextile placed, you can save many layers of stone and filter layers. Sometimes you can even use the sand and use these large bags to hold the embankment back. Then, of course, canals. The use of liners, of course, is one of the ways that geosynthetics developed. The importance of storing water or allowing it to flow without seeping away, keeping it clean. Very relevant in mining as well, where there's silts sometimes contaminated. And then landfill, of course, which is, I'll speak about later, but of course, there's many use of geosynthetics in landfill, a very efficient way of using geosynthetics. Dam construction as well for protection of the surfaces, stability, etc. Tunneling for drainage and lining. And then getting slightly into the buildings sector, but certainly the use of earth and the ever-growing, excuse the pun, use of green roofs and the idea of holding turf and wildflower mixes, etc. And then finally to, at the same time, hold back water as part of the SUDS or the water attenuation requirements of some governments around the world. So we're talking about replacement, and here's little old me holding up a roll of a geocomposite, drainage geocomposite, and with an estimate of the amount of stone that represents. And hopefully this illustrates my point. In terms of loading of a wagon, if you can reduce, say, on a roadwork, say a calculation where a roadstone of 0.5 meter is required, you can use a geogrid or a geotextile to reduce up to 0.3 down to 0.3 from say 0.5 meters depth of stone, and therefore saving on the amount of transport to site. And you can see the sort of calculations that we've made to show the saving, which is considerable. Now, what I thought to do was to look back over the 40 years and maybe beyond. And when I first joined a Dutch company, the Dutch are very focused on the first use of their geosynthetics. There's lots of arguments about who invented geosynthetics. I'm sure we could have a debate about that. But certainly a focus for them was when the floods in 1953 happened, this was an environmental disaster. And they said, never again. And one of the ways they solved it was to put all sorts of things into the breaches. They even went to the state of putting boats in, and as you can see, sandbags, etc. The trouble with the flows involved, they were too high. And it's where the company I work with talked about 8-ton polypropylene geobags being used, which was stable enough to hold the dikes back. And this started the work on the Delta Works, which has been dubbed the 8th wonder of the world. And you can see the geosynthetics already in use for the skirts. You see the size of the excavator there. These things are the size of a cathedral, and they were floated into place. And they used large amounts of geosynthetics in layers for filter and scour aprons between these large structures which held the gates. Now, in terms of sustainability, I'm just going to be thinking about where were we when we were thinking, well, the world was thinking about, started to think about sustainability. And it was around the 1960s that people started making graphs of carbon dioxide concentrations and thinking maybe this is important. But at the same time, mixed messages was, here's an illustration of how to get rid of oil into the ground. Just dig a hole and pour the oil in, and it'll all go away. But it was with the moon landings where it is often reckoned that the first most influential photograph of the Earth from the moon made us aware of how fragile we really are. My notes in black are to do with the geosynthetics, and the blue is just to say where we were at in the world. So in 1970s, the development of geomembranes and the United States Environmental Protection Agency was established. And this is an illustration of a project from a paper from JP on a double-lined reservoir, which is still here today doing its job. Of course, the great success story for geosynthetics and sustainability is the development of the landfill. Many uses of geosynthetics. Previously in the 1970s, there was dilute and disperse, a bit like the oil argument, and it was put in quarries, etc. And it was in 1980 that the EPA accepted a study done by Bob Kerner. And it's nice to give him some respect here for all the work that he and his colleagues did in developing landfills along with other people in the world. So the composite liner of a compacted clay liner, an HDPE, the eventual development of GCLs, the need to drain leachate using composites or combinations with stone, and then gas venting layers, etc. And there's been an amazing amount of work published by the IGS and encouraged by the IGS to share this information around the world so that we can have safe, sustainable, engineered landfills. Then we move into the 1980s and 1990s, and there was the Control of Pollution Act came in 1980, and things like the catalytic converter was considered for cars. And it's around the 80s that the geogrids were defined. And then, of course, the IGS was established. At the same time, we started worrying about the ozone layer depletion and how the ozone holes found in the Antarctic. And this is caused by CFCs. And the worry was with the UV radiation, the effects on human health. this is around when geosynthetic clay liners were developed, where you could have a thin layer which represented a thick layer of clay, which again saved vast amounts of carbon. There were full trials going on for looking overtopping of dams, because the consideration was the rainfall was going to get higher and there was a worry about climate change, and all the earth dams that were built could be overtopped and could actually fail. And then the concept of looking at geotextiles or geomats, helping grass do its natural work, and thinking of grass not just as something that looks pretty, but as actually engineering material. So there were full scale tests done in UK. I know there's done some in the US and possibly in Poland as well, where water was traveling at 8 meters a second, and we could start getting some limiting storm flows. I was pleased to be involved with that project, the one in England. Then the first intergovernmental panel on climate change was set up, and the United Nations had a conference in Rio where the UN Framework Convention on Climate Change occurred, and Japan's high-speed rail, geosynthetic reinforced soil walls, and I know Fumio is going to be talking about that, was shown to be an extremely efficient way of building walls, especially in an earthquake zone. Then the European Landfill Directive was put forward, and if you like, the legislation was there that if you allow the earth to be contaminated, you had to pay. So polluter pays, and therefore the high technical requirements that could be provided by geosynthetics were fully employed. Then we moved into the 2000s, and the awareness is slowly getting higher. There were films like the Erin Brockovich groundwater pollution film about challenging big companies who weren't looking after the soil and starting to make people ill. And then there was the use of high-strength wovens being used to cap contaminated silts and restore dockland areas. Of course, the Venice scheme was one where Venice was being flooded regularly. A large amount of geosynthetics were used to actually restore Venice to its former self, and to prevent flooding and the contamination that came with that. There was introductions into monitoring of geosynthetics using electrical and optical detection systems. Then the Groundwater Directive came in, and then again a groundbreaking or a newsworthy film was The Inconvenient Truth by Al Gore, where we started thinking about the air and what was happening to carbon. At the same time, the Rock Manual was produced, looking at saving layers for coastal defence works, and the invention of the use of these geotubes, which could pump silt in and mixing chemicals to start to form clay, so that you could reduce the amount of contaminated clay and lock that in and put it to landfill or in a safe place. And Bath University started publishing the embedded carbon values of all the different types of construction materials that were being used, so people could start to actually calculate what carbon was being used. There were standards set up by various governments. In the UK, there was a challenge that was set out in 2013. And the targets were things like, we must reduce costs in construction and get faster delivery and improve on our exports. And one of the things that came from the contractors, particularly in the agreement, was to reduce the amount of time that the construction was going on, and therefore improve on safety. So safety was put as an absolute priority. And of course, the main one is lower emissions, and the target was 50% by 2025. So the 2010s were really the dawn of the real recognition of sustainability and what it can be done. And the RAP report, which was produced by a supporting advice group for the British government, where geosynthetics were actually published as and calculations were made of carbon usage compared to other traditional methods. And this was quite an important step, certainly in the UK and I think around the world, to get engineers to think about geosynthetics. And in 2012, there were 7 papers produced, sponsored by the EAGM and presented in Eurogeo Valencia, with various applications of, as I've described before, with actual carbon values of the comparisons. At that same meeting, there was a plan to produce the IGS sustainability video, which I encourage you to look at, with JP, as you can see there, holding forth and inspiring and summarizing what we are talking about. In 2014, there was a mention in American legislation on water resource reform on the use and recommending geosynthetics. And then the 2015 Paris Agreement, where net zero was targeted for 2050 and global warming was targeted for no increase of higher than 1.5 degrees. There were published manuals on SUDs and to prevent flooding. And the UN set out its 17 Sustainability Development Goals, which was mentioned in Dr. Tooze's presentation, 2018. This was all started as well by Neil Dixon with Global Challenges, Geosynthetic Solutions and Counting Carbon. And Dr. Tooze's talk really set us some challenges. And she told us to be leaders and not followers, and start to really push this message out. And the way we did that was to set up the Sustainability Task Force, and then finally the Sustainability Committee. So that's taken as a quick run through, and now I'll hand on to Kasia.
Thank you, David. What a fantastic review. Took us for a little time traveling expedition. I am sharing my. Am I sharing my screen now?
Yeah.
It's here. Okay, so hopefully you can see that. So David took us through the historical review of what's been happening, and I will talk a little bit about where we are now. Where we are now as a humanity and as the IGS organization. So I will start with a little bit of the dramatic statements here. So very recently, just a few weeks ago in September, NASA reported that Antarctic sea ice is at a record low. And it's not just a one-off, it basically shows us the trend over the years that the ice is melting and decreasing in size. The next, not so positive news from the just general Earth state is about the planetary boundaries. So a number of scientists came together and mapped out a few important categories in keeping the Earth at the balanced level. It all started in 2009, and with still a few boundaries that were not well quantified. Then 2015 was presenting us with a few more boundaries mapped out and showing the transgression into a dangerous zone. So you can observe that the green areas in the different categories represent safe operational zones for the good upkeep of the Earth, and then transgression into red areas basically raises the alarm levels. This year, only a few weeks ago as well, there was a published update that shows that while the planet Earth is not really in a good state, many of the major areas are transgressed. So 6 out of 9, and that again rose some alarm bells. So human activity definitely affects the state of the Earth, and it's not really going in the good direction for us. So where are we now? November 2023, the 7th exactly is today. We are actually 8 years after Paris Agreement. Paris Agreement was a very positive event actually in that all climate crisis fight. And we are as well just ahead of the COP28 in Dubai, which will be happening just at the end of this month and will last a couple of weeks. There is a lot of positive expectation actually out of this COP. We will see how it goes. Ahead of this COP28, the Global Stocktake report was published. It's also only a few weeks old. It was published on the 8th of September. And it presents the review of hundreds of documents and reviewing the situation of what's happening in different countries and how the mitigation of the temperature rises and how the tackle against greenhouse gases emission is going on. So it provides some 17 of key findings. I'm not going to share all of them. However, I've got here some quotes from this report. So the world is not on track to meet the long-term goals of the Paris Agreement. And I think this is not the only report that has been reporting that situation. There's been actually quite a few of publications that were already indicating that we are falling behind. It's been highlighted that rigorous accounting and accountability are needed to lend credence to parties' contributions, track progress with environmental integrity, and avoid double counting. So better ways of quantifying those mitigations are required. And there is a couple more quotes for you. You can read them yourself. But well, for globally, to the humanity, this is not a really positive news. However, I think that, and these are definitely unprecedented times in my lifetime and in the IGS's lifetime. We've never been in the situations like that where the risks and anxiety probably about the future of the planet Earth has been so high. We as well don't entirely understand what are the consequences of our behaviors. We can see and we can observe what's happening on the news, but I think that we still don't really understand what's gonna be happening in the future. However, I don't want to be all that dramatic and apocalyptic. Here is a little snapshot from another report, Net Zero Tracker 2023, which represents pictures what are different states and different countries doing to mitigate, not what they're doing, but quantifying the net zero targets and or other means of mitigations within the different companies. And I think that this is quite a positive picture that shows that the countries of G7 or European Union states are actually trying to implement different legislation pieces and trying to limit those greenhouse gases emissions. So we can observe that up to 80% of different states are doing something to combat that temperature rises, which I think is a positive news. I think it's going to be only going better. Those green and blue bars going to be increasing, and those no targets elements going to be disappearing with time. We probably not at the time we are not in the situation where the 2050 targets can be reached, but I think it's going to be only accelerating and going and getting better. So that was the public sector. Now just moving on into the private sector, which is as well a quite interesting situation that we can see that here are emissions targets mapped for the 2000 companies, from the 2000 companies that are the largest by the annual revenue, and whether they have they have some mitigations or targets set or not. And we can see that a lot of companies within the countries of G7, EU, USA, and the rest of the world as well. China is one mapped here as well. But we can see that, well, globally, over 60% of those largest companies, they set their targets, they've got some mitigations in place. And again, those bars are, I think, with time only gonna be increasing. So I think this is a very good news to us, to the humanity, to the planet Earth, but to the IGS as well, because it means that more and more companies pay attention to those CO2 emissions. And we know that, and David was showing that over past 70 years, I think David showed us that we've been involved in those greenhouse gases emissions reductions in the projects where we can reduce those. So in terms of these companies, many of those companies come from all sorts of different sectors. Those companies can be come from the fashion sectors, from the IT sectors, from the construction sectors, and they do sign up to all different initiatives that can help them map out and set scientifically based targets. So here is another snapshot just from the same report, Net Zero Tracker, that compares different initiatives, what they involve, what they don't involve. But if you, for example, go and investigate a little further one of the initiatives, you will find out that different companies, construction companies, large construction companies from states, recognizable brands from fashion, consulting companies, engineering consulting companies, they do sign up to those initiatives, and they really want to drive those changes within their own organizations, have targets, achieve those targets. Interesting thing here is that, for example, offsets achieving interim emissions reductions. So, like, for example, tree planting is not necessarily considered within those estimates. So it needs to be like realistic goals and tangible goals for the company, not necessarily buying credits. So this is a little bit globally an overview of what is happening. Now let's switch to our construction industry, the closest to our heart. So globally, annually, at the moment, it's estimated that we are emitting roughly just under 40 billion tons of CO2 into the air. So it should be actually gigatons. A billion tons works better with my imagination. So 40 gigatons being emitted of greenhouse gases into the air. 40%, nearly 40% of those 40 gigatons is actually construction industry contributing to those greenhouse gases. This is according to United Nations Environment Program. They estimated. And it makes sense. I mean, on one side, we are building all sorts of engineering projects to improving the efficiency and productiveness of our lifestyles. But at the same time, those numbers very quickly ramp up. If we see how much 1 ton of aggregate, concrete, brick, or steel generates, those numbers really ramp up, and we really start with even small projects. We can, in the construction industry, we can actually generate a lot of tons of CO2 emissions. The good news and the fantastic news for us is that we are fortunate enough to work within the part of construction industry that has inherently attached carbon emissions reductions into our solutions, which makes myself proud actually to be engaged with that. So IGS, as David was indicating, best part of 70 years has been reducing greenhouse gases emissions in the construction industry. And IGS does, I think, fantastic job with promoting those different solutions. So as David mentioned, from 2019, as the task force sustainability has been launched and it's switched into sustainability committee in the 2020, the committee has been very active in promoting the good message, the positive publicity about the geosynthetic, just increasing the knowledge and awareness amongst the public through the social media. So I hope that many of you came across the Did You Knows that's been generated by the committee. They're available through the LinkedIn. And another element that's been quite recent, so the sustainability case studies. These were as well, these as well produce a good message. Each and every of you can submit your own project, and map it against SDGs, Sustainability Development Goals. So these are the colorful squares at the top of the templates. You can go to IGS website. And so this is actually a snapshot of the website, if you can see. So just go to Geosynthetic Society, to the sustainability part of it, and you can access here on the right-hand side the template, put your information, map your goals. This is going to be reviewed and published in a fairly swiftly manner. So do not hesitate and just go and promote your projects. There are other activities that Sustainability Committee does, journal and conference publication. Probably the most recognizable, and I think the more important one of the activities is as well presenting that one voice of the industry. So we are obviously, I think, around 2,000 members at the moment, but that's representing different areas of the industry. But having that one voice that can talk for us with the organizations, like, for example, European Commission, I think is a very powerful tool. And IGS, I think, has been doing a great job representing all of us here. There is a lot of as well resources available on the IGS sustainability website. One of the recent activity that's been run by the committee was as well was the second survey, the sustainability survey, that's been sent to the members, and the members represent the different areas, from the designers, manufacturers, salespeople to the testing as well companies. And I think that the very positive element of the survey showed that the majority of the members feel that IGS is doing a good job promoting the sustainable benefits of the geosynthetics. However, for the committee itself, the most important element of the survey is actually your feedback. So this year, the participation in the survey wasn't as good as last year. So I'd like just to encourage each and every of you, next time you see a link from the committee asking you to fill the survey, please go and do that and provide your own observations and feedback on what actions, on what else you would imagine you would like the committee to do, because this gives us as well a good idea and good take on what we're doing right, on what needs improvement, or what are the areas that we have not considered at all. Another element that's been included within the survey was the EPDs, and there was no surprise around the questions on the environment product declarations. So the manufacturers are the most aware and the most probably fluent with using those, with getting the declarations for their products, running LCAs on their factories. So here I will smoothly as well move on to the EPD part of the presentation, where Sustainability Committee as well encourages all of the manufacturers to get the EPD certificate. So that allows you to track and quantify the carbon footprint emissions on your designs, on your products. Here is just something that David already mentioned as well. So this slide, this graphic represents the different stages of the product life cycle. Now, the most common EPDs address the cradle to grave stages. So from the manufacturing stages, construction, use stage, and end of life stages. There are still some EPDs that only address cradle to gate, but if you are a designer, just make sure that if you want to compare two different products, just make sure that you compare apples to apples. So cradle to grave with cradle to grave, not cradle to gate with cradle to grave. So the committee encourages all of the manufacturers to get those certificates on their products, and as well encourages all of your organizations to produce environmental statements showing net zero target and climate actions plans. And you can do it yourself, or there are as well external organizations that can help you come up with those climate action plans. The fantastic development of this year was actually as well producing the carbon footprint calculator. So IGS Sustainability Committee teamed up with One-Click LCA, and several case studies were developed which can be assessed geosynthetic versus the traditional solution. You will find all the information on the website, and if you are interested in exploring more that carbon calculator, there is as well a part of the website that talks about the frequently asked questions, and these will swiftly help you to get access to that One-Click LCA templates templates on that cloud-based software. Just to let you know, there are all sorts of calculators available, publicly available calculators. So in the UK, for example, National Highways, they've got their own calculators. Geosynthetic element is only a small portion of it. Actually, it addresses all sorts of activities when it comes to National Highways structures building. Network Rail in the UK as well, they've got their own calculator. Again, geosynthetic element is a small portion in it. European Federation of Piling Contractors and Deep Foundation Institute, they teamed up and they created good 10 years ago already their calculator, and it's all actually in the Excel spreadsheet type of the form. There is no geosynthetic in this one, but just letting you know that something like that exists if you want to compare maybe some sort of deep foundations with the shallow foundation solutions. In the UK, at least, the design consultants, they've got their own calculators as well. And many of the responsible geosynthetic manufacturers, they as well provide carbon calculators. Here I will stop for a moment because all of those calculators that I just mentioned, they actually include only this environmental aspect. It's not a full sustainability calculator, because sustainability, just as a reminder, has three main pillars. Ecological is only one pillar of them. Don't forget about the economic and social element of the sustainability definition. So some of the manufacturers as well give you the full economic assessment and the social assessment on it. So for example, construction time reduction, trafficking reduction, which improves the safety on the construction site, and so on. So it basically is the full sustainability assessment. In terms of what is next for us, well, sustainability, I think, to me, means fight against conservatism. IGS has 40 years, but I think that for many of us, well, for many of you maybe, I'm only 40 years old today, but many of the engineers and designers in this industry has been continuously fighting against conservatism. Even today, 70 years of the tracked record case studies, there is still plenty of engineers that are not that knowledgeable or educated in the field of geosynthetics. So there is still a lot to be done in the field of education. And here I just got a little slide showing you as well that in the project lifecycle, the earlier we can tackle this conservatism, the more potentially long-term benefits and sustainable benefits to the project we can bring. At those early stages, the assessments on the CO2 emissions, they may not be perfect. A lot of us are perfectionists, and we want to get these accurate numbers in place. But many of us will struggle at those early stages to get to this accuracy. So we just need to maybe not shoot off the hip, but we just need to get those rough numbers in place and just show the comparison. Don't focus on the detail, because it is recognized by this industry standards. Those early assessments, they are very rough, not very accurate. With time, this accuracy increases. So attacking the, and many of us do that, attack projects at the early stages, and trying to get our foot in the door early, so we can make those large changes later on down the project lifecycle. What's sustainability else? What it means to me, it means innovation. And innovation, what David was showing, is in geosynthetics DNA. For years and years, there's been new functions, new applications developed, new ways of using those products. The industry spends lots and lots of money to develop new ways of thinking, and yes, new ways of applying the products. As well, I think there is a fantastic progress made on the in the area of monitoring. I'm personally quite interested in the monitoring and where is this gonna take us in the future. There is continuously new and new instrumentation developed, whether it's for strains measurement, temperature measurement, leak detection measurements. So there is still a lot of positive and very innovative thinking within the industry. So this is my last slide, and I will just close my session with wishing IGS the next as successful 40 years as it's been so far, because in my opinion, it's been a very successful and very positive 40 years. And I'm just looking forward to what the next year is going to bring to IGS. And I will leave David with the final summary. And yeah, I will stop sharing for now. Thank you.
Thanks, Kasia. We'll have a little chat because we've got a little bit of time. There is one question that's been asked by our audience, so we'll address that as well. But first of all, happy birthday yourself. And it's nice to be able to celebrate with the IGS. I got a question for you, because you've been talking about your impressions of geosynthetics since you've been working in the geosynthetics industry. But when you were at university, was there, just to sort of get a quick survey myself, was there much discussion on geosynthetics while you were at university in your engineering course? And more importantly, was there any reference to sustainability?
Okay, so I did my studies 2002-2007 in Poland, and I think that I was quite fortunate that at the university that I studied, there was a Professor Bold who's been engaged actually with the IGS as well. Not too sure what were the years of his engagement. However, he was definitely one of those progressive, innovative thinkers. And for years, he's been actually engaged with geosynthetics. He had a doctorate students as well. And in the laboratory, we had some equipment testing geosynthetics. So I was fortunate enough, because I remember some lectures did address geosynthetics, not in the huge details. And I still remember that actually one of our lecturers, Dr. Angelika Duszyńska, introduced us to a French software where we did design some MSC rules. But I think it was very unique in the scale of the country, or I think even globally, because IGS spends a lot of time trying to improve education and visibility of geosynthetics at different universities. And I think what many of us observe is that when you go to the sites, when you go to the consulting companies, a lot of engineers don't really recognize geosynthetics as a traditional solution, as a solution with a long-lasting history. It's still a novel one. Sustainability-wise, though, that term has not featured, I think, at all in those years, not from my memory. I think that it's been a fairly recent, as you said, 2010s. It's really, yeah, sustainability. I came across sustainability term first time when I started studying in the UK.
Okay, well, I thought it'd be good to just answer. We do have a question. Then maybe you could ask me a question, and I can just wrap up. But the question comes from Mustafa. Are calculator results confirmed by Kiwa as valid for other authorities? And I think it's mentioning he's thinking about EPD certificates. Well, that's very specific to Kiwa, but as a notified body, I would think, like with their certification systems, they are accepted by authorities around the world, and that would be under their independent certification. So I would guess, I can't speak on behalf of Kiwa, be a good question for them, but I'm fairly sure that these notified bodies are able to have the authority that's required.
I agree with you, actually. My organization uses Kiwa as well.
Yeah, yeah. Okay, well,
all right. Before we maybe, okay, no, there is another question actually from Soilin.
All right, you just need to, do you want to cover that one?
So what are the future challenges and responsibilities of geosynthetics industry in the next 10 years? This is a very good one. I think that the challenge that we continuously, that the IGS continuously, and probably different companies, manufacturing companies, distributing companies, try to address is the education and visibility of the geosynthetic solutions. I think that still there is, it seems to be the lack of knowledge, and this is why the geosynthetic solutions are not considered as typically the first one, but rather as an alternative solutions. I think that would be my take on it. But David, do you have your opinion on it as well?
Yeah, I kind of like to share one last slide to wrap up, and it does kind of answer that sort of question. If I could just do that. Okay, right. Well, in the next, what we found is that we're reducing all these mineral materials that are being used, and just as Kasia's been mentioning, the calculators. Well, we haven't been idle. We've been doing these calculations, and they've been accepted by clients, and it has made the difference in real decision making in construction. And some of the examples, just quickly, and these come from real live sites. So looking at reinforced soil wall versus reinforced concrete, 57% saving on CO2, 55% saving in cost. Road structures, reducing the amount of aggregate needed, 55% saving in CO2, 50% saving in cost. Drainage blankets, the drainage stone being replaced by a geocomposite, 64% saving in CO2, 48% saving in cost. And the biggie, this is the winner I've found so far. I'm happy to be proved wrong because we're all in it together. It's concrete blocks used at the back of a drainage wall versus a geocomposite drain, 94% saving in CO2 and 55% saving in cost. So the basic message is we're doing a good job. We reduce, I would say, as an average, you could say that if you're going to use a geosynthetic, you can save roughly 50% on the carbon, and maybe similar, maybe a bit less on cost. So what we are is really saving the earth, but only if we do it. So I want to sort of herald what Natalie said to us in South Korea at the meeting, to get us to be leaders rather than followers, and to take challenge engineers to take greater risks, look at what's going on, and have that sense of urgency that's going on. You know, we haven't got time to play around deciding whether something will last 150 years in perfect condition, when we're talking about climate change, which could mean that we've got to challenge what this planet will look like in 150 years. And I think it's about time civil engineers started being a bit more philosophical and real. But we're problem solvers, and I think the IGS are problem solvers too. We have a solution which has been around for 40 years, and we've been talking about it a lot to ourselves. It's time we went and told others. And I'd challenge every single one of you to sign up as a member of the IGS, to go and volunteer to talk at a college or a school, to talk about how these materials save the earth. And we've got a challenge on, because one of the things that the committee recognizes that the message is plastics are bad, and they're all bad, which is a total nonsense, because it's a perfectly good construction material if used properly. The problem with plastic is people, and people litter things. So let's not fall into being labeled that way, and let's be positive and share this positive message. And I thank you, Kasia, for your positive view, and it gives me a lot of hope, handing on, as it were, to the next generation, that we're going to do some more good stuff. So thank you very much for listening, and I'll hand back to John.
Thank you so much, both of you, Kasia and David, and thanks to everyone who joined today. A very powerful message there about being leaders rather than followers, and getting out and speaking to everyone you can about the benefits of geosynthetics that have been proven. Don't forget that after this webinar, in just a couple of minutes' time, we've got our second event of today, which is starting at 8 a.m. Central Time, 2 p.m. Universal Time. We've got IGS Treasurer Professor Ji Han talking about the IGS's finances and how we'll ensure the society continues to build on 40 years of success to remain financially strong in the future. So please join us for that. It's on the same Zoom link as this session, so it's really very, very simple. We're going to close this session just to allow G to come on, and then we'll reopen it in 2 or 3 minutes' time for his session. So thank you again to everyone. See you in a few minutes.